Hi folks, I'm Geek here. This is the first time I tried to stream and capture at the same time essentially, and unfortunately we've had several glitches this particular con. Mostly my fault on these. In this case, the microphone was on for the house audio, but the microphone that was being used for the stream and the recording was not on for the first about 11.5 minutes. So if you fast forward to about the 11.5 minute mark, audio does resume, and I'm going to try to get this whole process a lot more reliable before I start doing more streams. Sorry for the problems, and enjoy.
I didn't have it on, sorry. It means a lot of devices in a lot of places, right? You have to get a lot of things. Now, that means in the typical IT way to doing things, that means, I got all these new servers or devices that I got to manage. I got to do stuff with them, blah, blah, blah. But if we steal some concepts from distributed computing, we can make this less of a burden. So, introducing the double-decker couch. We use sensors for the resources, right? Like a node in HPC. This is a sensor. We have to think of it as a worker node in an HPC cluster, right? So these things need to be throwaway. They need to be able to run on anything, right? How many people have gotten a server into Brazil? Have anybody tried to get a server into Brazil before? Yeah, it takes like months, right? So if they've got some server there already that's got some VM space on it, you need to be able to run something on there, right? That's going to happen a lot faster than trying to get a new server or device or network device out in Brazil, right? And again, like I said before, you've got to manage this thing as one thing. So when we talk about management, I use Salt. You can use Chef. You can use Puppet. There's all kinds of different ways to do this. But I prefer Salt. That's just what I do. So typically when I look at large deployments of sensors, the awesome part about Salt is it has GitHub integration. And what that means is now I have change control built in. So when the PCI people come bugging me about shit, about saying, hey, do you have controls in this place? Do you have this and that? I just send them to GitHub, right? Here's our change control. Here's where we approve the pull request, et cetera, et cetera. So we get that crap out of the way really easy. And then the master of masters. So the master talks to the minion masters, and then the minions talk to the minion master. And the reason it's separate is just from a security controls perspective. You don't want your little worker bees talking to the top of the thing. So what happens is these minions, they check in a predetermined time frame. So I typically use 15 minutes. And when I have them log in or check in, I make sure that the state of that sensor is what I want that sensor state to be, right? So if somebody gets on there and screws something up, I want it to automatically fix itself. I don't want to have to do stuff at all, right? Because if I've got, and I'm talking thousands now, right? I've got a situation where we're putting in thousands of these devices. I don't have time to get an innocuous alert that says, bro screwed up on this machine. Okay, then I got to go connect to that machine. No, that's got to be all automated. Or this service or that service is messed up, so it has to be able to check in and make itself to that golden state or golden image or whatever all the time. And by doing that, that makes managing all these devices. The only time I have to mess with the box is when some hardware fails, right? If I lose a drive or something like that. That's a lot more infrequent than, lots of open source tools have memory leaks and things happen and some weird packet comes through and it crashes the service or something like that. That happens a lot more often than dropping, say, a hard drive in a box. So by doing that automation, it takes a lot of that burden. And nobody wants to log onto boxes and add users or any of that crap. Nobody wants to do that. I don't want to do that. So how can we do this, right? How can we do this right? I would say anybody know what movie that's from, but it kind of ruins it since it's in the quote. So again, what I was talking about before, we need to make sensors throwaway devices. It should be able to run on a Raspberry Pi up to like a 8 processor, 64 core box with a gazillion gigs of RAM. It should be able to do that, right? But to be able to do that, we need to pull the atomic indicators off the boxes, right? So the atomic indicators, things like IPs, DNS names, and notoriously things like Snort have a horrible job at processing atomic indicators. And this is where I talked about the earlier question, right? So you've heard it mentioned a couple times, and people give me some shout outs about, detect all the things and what that does to the grid. A lot of my time has been spent, how do I protect my sensors from analysts, right? So when I asked the question on who uses perf profiling, nobody raised their hand. But lots of people have written snort rules. So when you have a grid of, say, 500 sensors, and you roll a signature out there that causes 98 or 99% packet loss because it's horrible, I've got to go fix that. I've got to go take that out because you didn't test it, right? There's not stuff going on there. And it just happens, right? And sometimes you have no choice. You have to roll a crappy indicator out of there. So how do we address this, right? How do we make it so that we can do this and still use these low power devices, right? So just to give an example of how these things are built, and it's going to be a little small, and I apologize, so I'll just talk through it. So what I'm doing here is I'm just checking, I'm using Salt, and I'm using the PKI piece of this to authenticate the Minion to the master, right? So the Minion is on the right, and the master is on the left. So I'm going ahead and I'm accepting the key to say, hey, that's cool. And I've already filled out a file that's associated to the server that has some unique information, like its host name and a couple other things, like 6 lines, right? So my configuration of this box, sans the other thing, is just doing it. So I just check to see if Bro's running. It's not running. I just check to see if Bro's installed, just to show that this is a box that's a CentOS minimal install with just a script that goes that's ASHI to IP and all that kind of stuff. So now I'm just checking it in, and I've sped this up in the video, just for the sake of time here. But what it's doing is it's doing its initial check-in. So right now it's saying, okay, hey, I'm a new agent. I'm accepted. It just went and updated all the packages, right? First thing I always do, update all the packages. So any vulnerabilities that exist on that box, from a compliance perspective, saying, hey, this box has an older version of OpenSSL running on it, that gets taken care of. So now, after that, we are installing our custom compiled tools here, right? So this is where we're installing our Bro and our TCP dump and that kind of stuff. And if anybody knows anything about pfRing, is that you have to compile it, you have to compile a special version of libpcap, you have to compile a special version of TCP dump, all those kind of things to make this work. So you have to have these packages. You've got to go and create these packages yourself. This doesn't go into that, but these are just from a CentOS perspective, I just have a custom repo, a local repo, so to speak, inside, and I use yum plugins priorities to say, this TCP dump that lives on the local repo is more important than the one that lives on the EPEL repo, to talk Red Hat speak. So now it's going through, it's copying all the policies, everything down. It's installing Bro. So there went the policies. It synced all of my policies to it. You can do the same thing with Snort or Suricata, sync the policy. So if you have a rule change, right? So let's say you have one of these crappy rules that you want to roll out there to blow up the grid, you can do that every 15 minutes. So the good part about that is when you find out that, hey, my rule was horrible, it's only 15 minutes of pain from that perspective. So right now, Bro's, I think it's starting. Yeah. So I'm starting Bro. And then essentially what I do from here is, in the video, I just verify that Bro is installed. I had to put in some sleeps because there's some, if Bro install hasn't completed and you try to start Bro, it can cause a little thing. So it can get a little finicky. So it's done, right? So now this sensor has been built. Now, this process, I did it over the internet, right? So, there's Bro running, and I do a list of the packages that I did. But the reason I do that is, so now I don't have to do anything, right? I actually, in my new version right now, I just have an automatic reboot at the end. So that was my touch point, was logging onto the box. I can actually even automate it even more, which I do at a current customer I'm using, where we've got like close to 500 sensors, and we're going up to big time from a number perspective. But when that box comes on, once they do the initial configuration, when they boot up the box and they say, what is my IP, what is my net mask, what is my default gateway, it reboots, and the first thing it does is it checks in, gets everything it needs, reboots, and I get an email that says, hey, you got a new sensor. And we're doing 40 to 60 of these a day, right? And we don't touch anything. right? From the standpoint of the management of the device. You still have to have somebody typing in those things, but once they type in that information, you're good to go. So all of that's neat, right? Taking all this stuff and making it dumb and pulling all the stuff down and doing everything. How do we, if we take the atomic indicators off the box, how do we do detection now, right? I mean, that's what we're here to do, is to do some detection. So what you do is you break things into a service-based architecture, right? We want to centralize the data, not the devices, right? We want to get as many eyeballs out there as possible and then pull the data in where we can process it for a lot cheaper, right? If we can process the data, I mean, if at your company, which is faster, getting a sensor in your data center or getting a server in your data center or getting a server into Brazil, right? So that's one way. And then you can take the cloud. So if you're using the cloud for this, is it faster to get a server inside your data center or faster for you to go to AWS or Azure or whatever and click a button and get a server, right? So these are this gives you that flexibility to say, okay, I have a crappy rule. I need to be able to do more analysis than that needs to happen. So by breaking it up into services, it gives the ability to scale it, right? So we talked about, the detection stuff, but you still need to do your deep packet inspection. So if you look at the emerging threat rules, you'd be surprised on how many rules in there that you can use straight up bro logs to detect what they're detecting, right? So you can pare it down to the things where I need to do bit jumping and really get into the packets, that stays on the sensors, right? There's no getting around that because you need to be there. But all the atomic stuff, right? So when we had the detect all they had the detect all the things thing up there, you can detect all the things. If you want to buy enough servers or pay enough money, you can, right? So this was my solution to the analysts wanting to do all these things, wanting to detect all the things, but not having them do that by causing a major packet loss event, right? Because I just get behind in this thing, I don't lose packets. So to do this, you get into the pub sub realm. So I try to do a little awesomeness there with the pub and the sub. So what you can do is you can ship bro logs from your sensors, right? That you can check them for thousands and thousands and thousands of IPs. Now, Bro does a pretty good job of taking atomic indicators and making something useful with that on the sensor. So it does a pretty good job from a performance perspective. But you're just limiting yourself to those atomic indicators to one spot. There's other logs that stuff can be applied to. So you can have subscribers to your, and these are terms that happen in the whole RabbitMQ, Redis world. I'm not a huge person into that, but you have the ability to have these what's called a fan out, and then you can have multiple subscribers. So what I can do is I can have a fan out, what it does is it sends the same event to whatever subscribers it wants. But I can then have part of that fan out talk to a bucket that then has like a load balanced flow, right? Where it says, I come in and I grab an event, I grab a log line from Bro, right? From the con log. I take that out and I search for all of my atomic indicators on that. Or a DNS log, I search for all those domains. I could have millions of domains and I could search that really quick on that device. And if I put something out there that's horrible, it just takes longer for that process to happen. We don't lose packets. We don't lose the traffic. So, and that's a key thing. And that's what I would always run into when analysts would put cruddy rules out there was, you'd have that situation where you would lose packets. I mean, 90%, if you used, I'll tell a story since everybody's been telling stories. So we had what was called the IP watch list at a company I worked at. And I won't name names. So it had thousands and thousands and thousands of IP addresses in it. And I don't know, This was before the snort, what is it, IP reputation stuff. So what it would do, it was basically a rule for every IP that they wanted to look at in domain and all that kind of stuff. Just thousands and thousands loaded onto every sensor. Now, does anybody know how snort processes those? So when you look at snort, let's say you're using the HTTP preprocessor. It makes sure, and then in a rule, you can say is established, right? So you can take that snort rule and you can say, first, hey, is it HTTP? Yeah, right? Is the connection established, right? Is it, if it's just like a scan or something, I don't care. Is the connection established? Yeah. Okay, now do work on it. Well, with an IP, every single packet that box sees has to run through that list, right? So even though it could be one host talking to another host, it's going to look at that connection for every single packet. It's going to have to run through the ticks on the CPU for that. That's horrible, right? So they came out with the IP reputation thing, which was great. It did it a lot better, but the problem was you couldn't add context to it. So now I've got we've got an alert on some IP, but I can't associate it with anything. I just know that it was on my watch list, which kind of sucks. And that's where the bro shines in this thing, is because you can do that quickly and you can have that context to what it is, right? But they rolled it out to snort because at the time we didn't have bro yet. And it went from, we had sensors, probably 400 or 500 sensors, and we went from, most of them having a below 5% packet loss to like 95 to 98% packet loss across the board. Just by saying, we want to detect all the things, right? Just by rolling that out, that was a situation. So it's always been this challenge and this thing of mine to say, okay, we've got this situation where people want to do what they want to do. Analysts want to do what they want to do. And my job is to enable that, right? So, excuse me. We get into this sample architecture, right? So I talked about a fan out. So you've got this log ingest piece, and so we're just talking bro logs at this point, right? You could send snort alerts right, via syslog to this thing. This can be a log stash. It can be a syslog ng, whatever. You can take it and you parse those log events, and then you bring it to something like RabbitMQ. And that's where you do the fan out, and then you can have things happen, individual rules. So you can do certain things that you want to do to those events. But what I said there, which is very important, is you can use logs too, right? So we've heard lots of talks today about you need these logs, you need to centralize, you need to do these things, how do I apply my intel to these other types of logs? Well, you've got this situation now that has created a way for you to take all of those atomic indicators that you have. So, I might have IDS boxes in a bunch of my locations. Other locations, I might have just firewalls. Well, guess what's in those firewall logs? Atomic indicators. But I know hey, if I see accepts from these, what I say are bad IPs, I would like to know that, right? But typically, you're not going to go into, say, a checkpoint console and scroll through there and find, you've got thousands and thousands of indicators. You're not going to scroll through there and find that bad IP, right? So, again, what we've done is saying, okay, we've sort of solved the problem about cruddy indicators. But now we're getting to the realm, say, because we're doing it the way we're doing it, we've enabled ourselves to use those same atomic indicators for firewalls, right? So we've turned that device, which is not really a detection device, into sort of an IDS in some ways. So you've got proxy logs, right? So if you look at like emerging threads, you look at a lot of the different open snort rules out there. They do a lot of URI processing and things like that. Well, guess what? That's in your proxy logs, right? I might not be able to have a sensor somewhere, or I might not have enough money to support that, but I have these proxy servers and they have logs, right? So I'm using that same intel, the same intel that I had from before, and I'm using that intel with my proxy logs. And then DNS is the same example, right? So you have a situation where you're logging all your requests, and you're able to take those domains. So you're taking those logs from your enterprise, and you're using those you're getting money out of your indicators that you have, right? So you don't have antivirus rules over here and, giving you stuff, and you don't have another set of intel for IDS, and then you've got some IPS device over here that supports some other kind of intel framework that you have different stuff over here. This gives you a way to centralize that. So this was really coined from a talk that Dave Bianco did at BSides Augusta 2013, and the link is there to watch it. It's a very interesting thing. They talk about using sort of changing the way you do detection by pulling in all these other sources, changing that example of I'm looking at we first started like just having like IDS, right? You had an ISS real secure device, right? And then you had a snort box, and then that wasn't good enough. So then you had NSM, right? So now you're doing full PCAP. You're doing all these different things, but now that's not good enough, right? You've got to keep up. So then the next step on that is putting the logs in there, and that paints the ESM picture. That could be an entire talk, and it is an entire talk, obviously, on here. So I suggest if you're interested in knowing about it, it's kind of branded Mandiant on the thing, but it is a very interesting talk. So after all this blabbering, what have we tried to improve here, right? So we can use MPLS now, right? So I can see traffic between user A and user B that are at two different sites, right? So when they're using those @ commands, when they're using the PowerShells between the boxes, and it's an MPLS network, you're going to see that, right? Until they allow OpenSSH for that PowerShell stuff, and then you won't see it. But anyway, you will see that, right? And you can use asynchronous routing. You're always going to have this no matter what, right? But just because that's how BGP works. But like I was saying earlier, it's very important that from a detection perspective, we don't get in the way of networking technology, of what they want to do. We won't talk about IPv6, but because nobody wants to go to that. But it takes that conflict out, right? It moves it away. Now, another thing, and I didn't put it on this slide, is by moving some of your detection off of the sensors and bring them into a center point and pulling all these logs in, you've moved the spend from your networking team budget to your logging infrastructure bucket. So I'd heard Splunk dropped a couple times, right? It's kind of pricey to do those things, which means there's normally larger budgets that you can go after to implement these tools, to implement this stuff, right? So that's very important. You can get that we talked about the optimization, you get that. And it gives you more eyes and more places to detect that lateral movement, right? So at a place I worked when we started with 6 or 7 sensors. We had lots of adversaries in our network, and we're like, okay, how do we go after these guys? How do we get them, right? So the first thing we went to C2, right? Obviously, right? There's C2 is kind of for the most part, it's pretty easy to pick out sometimes. This was a long time ago, so it was really simple. They didn't use any encryption. They didn't have to be fancy because it wasn't required because nobody's looking, right? So you go after the C2. So we went after the C2, and we did, we wanted to get them out, right? So you cut off that C2 by detection, right? We were just doing this with detection. There was no whiz-bang device that we stuck in there that said, oh, this is C2, and shut it down, right? Because this was a long time ago. But because of the detection there, we cut that avenue out. Well, then what did they do? The next piece was they were using other ways to do that C2, right? They were, instead of controlling from a server, they were actually logging in. And you saw people talk about using RDP, things like that. So they were just logging in. Okay, you take away my C2, I'll just manually go out here and do stuff. Before it was easy. I just click buttons on my web shell over here and, everything happens. So we went after that. So we went after that exfil. So, the passworded RARs, encrypted RARs, right? Those were like common techniques at the time, so that we started detecting that. So if I see an encrypted RAR file going out of my network, chances are Joe Smith in accounting is not encrypting RARs to send an email to his wife or something, right? That activity doesn't occur generally. So by doing that, you would see I've got an exfil event. Well, then what happens is they see, okay, you're catching us, right? And this is the whole TTP discussion we had. And just a side note, in that presentation that David gives, that's where he introduced the pyramid of pain that was shown by Harlan. So, this is where we were doing things to the adversary. We were shutting down their avenues. We were shutting down their access, and they were adjusting to our TTPs, right? So they're saying, okay, you are not letting you guys can see when I try to get these RAR files. And does anybody know why they like to use RAR files to get stuff out? So they like to use RAR files because if you zip something, the checksum information is at the end. So to unzip a zip and make sure everything works good, you have to get the entire thing. Well, these guys if they're moving lots and lots of data, it could be terabytes of data, who knows? They're trying to get it out. Well, in RAR, it's in the beginning. So if they cut me off midstream, I've got at least half of what I wanted to steal, right? So I take that, whereas a zip, that data would be useless. So they know that because they're going to be blowing up your internet connections. They know it's going to be loud. They're going to put they're going to put their stuff, the important stuff at the beginning of that because they know they're going to get caught, right? They know that you've got that detection. Well, that became not good enough for them anymore. So then it became lateral movement, and this is where it's important. So now you have third-party connections. You have some site that you acquired, some company 100 years ago, and they have an internet connection that had some cold fusion box on it. You didn't even know this site existed, right? And they've got a box there. So now they're going around your network, going to your users, right? They're not going to your data center. They're going to your users because that's who they're stealing their credentials or doing whatever. And they're taking that data and they're just moving it laterally to these places where they have connections. So my internet sensors that I've got out there, I don't see anything, right? There's nothing that going on, right? If I don't have that visibility from a lateral movement perspective, then I don't see that. So they can rob me blind, and I'll never know. So by making this a low-cost option, by putting out there, I mean, in totality, doing this is a challenge because you've got to do something with data. And I know I sort of made it sound easy, but taking all this data from all these different log sources is a very big challenge, right? So we talked about the process logs and all those things and the whitelists and sending all that information to a central point is very difficult. But at least by putting in a service-based architecture is that we can start to scale this of what we want to do. So if I start small, I only have a certain amount of log files coming in. I can start with maybe one rules box, right? That's cranking through. It's just doing PCRE detection. It could be written in Python. It could be written in anything, right? It's just going through and looking at these things, right? So as I add more sources, I can add more stuff in my rules. If I need more stuff to index this information, I can add more indexers. I need a bigger, longer archive, I can put in more disk or whatever. So it's very important, that I stress to you that it's not easy and it's not something you can do. There's lots of people trying, with the Elk stack, a lot of people are trying to do this. And there's some great resources around that. And I'll try to tweet out some of the resources on the Elk project. But there's a lot of people trying to do it with that. There's ELSA, right? There's all these different ways that you can take this data and you can look at it and you can apply those indicators across all of your data. So, really if I could summarize this real quickly, it would be take as much off your sensors as you can so that when you can do it centrally where it gets more bang for its buck, right? So you should never have to look for, do I have a bad IP on a sensor ever again? That should always be done centrally. So questions? Nobody has any questions? Oh, I'm sorry, I didn't see you. Third-party connectivity, right? That's a big one, right? And if a company wants you, or if an adversary wants you bad enough, I worked at a company where we did a press release saying, "Hey, we're going to buy some such company," right? That's like an open invitation that, hey, this is some small company. They don't have a huge IT security team. I'm going to go own them. Because I know at some point you guys are going to turn the network up, right? So, I mean, hey, but that's the persistence part, right? They're willing to sit there for a year until you finally get around to saying, okay, come on, you can come into our network now, right? We've done all of our assessments to see, they're talking about Coleman was talking about doing assessments on the network before you pull it in. Well, these guys are using tools that nobody's ever seen before, right? And they're willing to burn those tools and wait for you to bring that connection up. And then once they do, they've already got a plan of attack on you, right? Because they know your environment. They've been hitting you for years and years and years. And by knowing that plan of attack, as soon as that connectivity is there, they can go and start doing their things. They know exactly what they're going to do. They could get they might even have like a beacon that goes, once a week that says, hey, I still can't connect to that one server that I know that I need to get all the goodies from, right? And then one day they get a response from that server that says, I can get to that server. And what does that do? That's, they call up the on-call guy and he comes out and they start owning your network from there, right? So, not to say that that would ever happen, but, any other questions? In the back there. Like, you've got to do to really do it, you got to do man in the middle. Like, I know there's some products that claim they do it. I think if you use the problem is that kind of stuff is really expensive to do, right? So man in the middle is the cheapest way to do it. And for people who don't know what it means I say that, your Huntington Bank certificate is actually my certificate. And then I make the connection to Huntington Bank on your thing. But since that's a valid trusted certificate, I don't get a certificate warning, but I'm looking at your bank account information on my proxy because you're doing that. Well, if you're using the right kind of SSL setup, you should be using like it's like a Diffie-Hellman something or other where it's impossible to crack because it's a randomized key that tumbles or something like that. So it makes it very difficult to do it reliably. And that's why when I talked in my encryption slide that, you can go with man in the middle, you can go with termination, but if you've set up your web servers correctly, there should be no way for them to crack the SSL connectivity unless there's an open SSL vulnerability. But I think even when not the recent one, but the big one, I forget, probably had a logo and all that crap. When that one came out, that type of SSL connectivity was exempt from it because that key tumbles, right? So it makes it hard to do. And I wish I knew offhand. The Google machine will probably be able to tell you exactly what setting that is. But, most of your banks are using that, right? So that you can't, but when you do the man in the middle, it doesn't matter, right? Because they're tricking you. And, I saw somebody did an article recently in my Twitter feed talking about, how many big companies do man in the middle attacks. Or, I don't want to say attacks, but do man in the middle you. And they put you at risk. So if you're on your work machine and you want to check your, your health information from a public health, from a site that's, that's not on their network, they've exposed your information, your PII, at their proxy level. So if I'm going to if I know you're doing man in the middle attacks, and my goal is to have PII or to gather passwords and gather this kind of stuff, what would I target to get that, right? I can't, if I'm just on some box that's on the network, it's like I could own your IDS server, I can't see that. But if I own your proxy, I see that because it's actually the one doing the man in the middle. So and it can log all that crap, right? So, you got blue coats and things that do that. So they're actually dumping information. So I'm sure if you're savvy enough, you could probably pull out certain fields in that URI or whatever that's been in the man in the middle that you can grab that information that typically would not be there had it not been attacked, I guess you could say. Any other questions? Sorry, I can't really see. Cool. All right. Well, thanks, everybody. Appreciate it.